the first, like
Yeah,
previous
yeah,
slide.
from okay.
Yeah, our topic is BachGAN for high resolution image synthesis from salient object layout.
Hi everyone, I'm Ayush Kumar.
I'm Saurabh Ansali.
And I'm Vinay Upai. Next slide. Yeah, so the problem we want to solve or the objective of our project is to get high resolution realistic images from object layouts. Generating realistic images has always been a frontier of computer vision research. There has already been considerable work in this field, with inputs such as text, scene graphs, and semantic segmentation maps being used to specify the details of all the objects we want in that image. But our aim is to simplify this input to make it an object layout. That is, we just specify the bounding box and labels of all the objects in the image. And to do this, we use a model called Background Hallucination Generative Adversarial Network, or BACAN in short. Yeah, next slide.
So GAN is a very crucial part for this kind of problem. Like every other paper has been used this GAN to generate images. So for image generation, it's a very crucial part. So for GANs, we have two kind of convolutional neural networks. One is a generator and second is a discriminator. Generator uses a normal Gaussian noise to generate an image, and discriminator takes input as a generated image or a real image to discriminate between them if it is a generated uh, or a real image. Mainly, we can say that a discriminator is a CNN classifier and generator is a reversed CNN classifier. So that's how this GANs normally works. Okay, next slide. So here we can say that this is a reversed CNN in which we are inputting the Gaussian noise to generate an image, and in the generator we are inputting an image to generate a Z, which would be the yes or no, which would state that if it is a real image or generated image. Next slide.
Uh,
Yeah,
since
so
the
wait.
proposal,
There are many kinds of GANs which are being used. There is one is a text to image generation, and second is a graphs to uh, graphs to image generation. So in both there is input as a graph, and in the second there is input as a image text which uses these GANs to generate images. Now, Ayush, go.
so the first part of the input can be taken as text. In the attentional GAN that was proposed in 2018, they took a sentence which explains the scene, and the GAN interpreted it to form an image. However, the problem with that was interpreting complex sentences. When there are multiple objects in this described in the scene, the a good high resolution image was not being able to produce by the model. The second input that the model can take is scene graph. Scene graph basically explains the relationship between different objects present in the text. It was proposed in 2018 by Johnson et al. Uh, but due to the lack of object size, location, and background information, it limits the quality of synthesized image. And thus, high resolution image cannot be generated through them. The third part is segmentation. The third input that model can take is segmentation map. Segmentation map is the basically object layout of where different objects is. But due to the difficulty of generating these maps and getting input data, these input choices can be difficult to train the neural networks. In these images, as you can see, the first image has been taken from Johnson et al., in which relationship between words have been established, and the GAN is able to produce the synthesize an image. In this second one, a text has been taken as an input and the model was able to synthesize image. The third is an example from Park et al., which has taken segmentation map from COCO dataset and has synthesized an image corresponding to the segmentation map. Next.
Yeah, so one part of our project is to generate images from object layouts which are easier inputs, and the other is also generating high resolution images. Until 2018, conditional GANs were used to generate images, but these GANs, conditional GANs, couldn't produce high resolution images because of instability in the training stages and issues of optimization. Now, this can be overcome by using a perceptual loss in which high resolution images are generated, but once the aspect ratio is changed and you zoom in, there is a lack of finer details and texture. This training instability can be overcome by using multi-scale generators and discriminators and using different objective functions compared to conditional GANs. Next slide. As you can see, the state of the art in 2018 was using cascaded refinement networks, and that is the image being generated at the top, which as you can see is not that high resolution. And below is the image you get after using multi-scale discriminators and generators, which clearly produces higher resolution images than before. Next slide.
Ayush, that's your point.
The normalization layer is used in all the convolutional in the all the image generation model. So basically, first batch normalization was used until instance normalization was introduced, and most state of the art has used instance normalization. However, spatially adaptive normalization was introduced in 2019, in which generative model takes semantic as input and they pass it through the SPADE or spatially adaptive normalization layers. What space normalization layer does is it learns the parameters through the input itself, and thus is spatially adaptive. The problem with this normalization layer was that they to wash out the data present in the initial layer of input, and hence a high resolution image was not being able to generate. So in SPADE, they took several, they took an input mask and parameters were based on the input mask itself, and the semantic information was preserved in SPADE. As you can see, using a segmentation map, images being generated, and with the SPADE normalization layer, that is the right hand side layers, high resolution images was generated as per the given segmentation map.
Yeah. So as we have already explained before, object layouts are the easiest inputs that you can use for image generation. So by object layouts, we mean that we specify the bounding box and categories or labels of both of all the objects in the image. So one of the first papers that did this was Zhao et al. In 2019. So what they did is they disentangled the representations of objects into two, that is categories and appearances. By disentangling representations, we mean that different parts of the model or different neurons or different parts of the neural network are responsible for different features and they are independent of each other. In the same paper, the generators minimized the sum of 6 different kind of losses, and the authors have also performed ablation studies. Ablation studies means to find out the impact of each of these. So in one run, you do not take one loss, use the other 5 losses and see what the impact is. And they did this for each different loss and saw what each different loss is representing. Now the problem with this paper is that both foreground and background objects need to be specified, and the images generated were of low quality. Next slide. As we can see here, so this is what an object layout is. It's very simple and easy to use for even a layman. You just mention the bounding box such as road or fire hydrant and the labels, the road and fire hydrant text itself. Now, as you can see, it needs background and foreground objects in the layout, and the images generated are of low quality. For this, we propose BachGAN. Next slide. Yeah, yours.
Ayush,
BachGAN has been introduced to use high resolution to generate high resolution images from layout itself. The model selects a wide range of segmentation map and according to the specification of foreground object layout that has been provided as the input, and it generates a feature map which is finally converted to an image using speed normalization layer. Uh, so as you can see, these are the bounding boxes and corresponding tables uh, from which image has been generated. Corresponding to the segmentation map, the image generated is of low resolution and of lower quality, while corresponding to the object layout itself, the images generated are of quite high quality, high resolution. So this is how BachGAN works. BachGAN has basically three modules. The first is the background retrieval module. You can see on the left. It takes the it, it takes the object layout that has been provided as input and retrieve a segmentation map from a large bank, and it takes images from these banks and choose the rest of the images which suit the corresponding object layout. The image is chosen on the basis of intersection or union metric. Then that is passed to the background fusion module. Since only one image cannot satisfy the whole layout that has been provided as the input, what this module does is select the top N segmentation map that has been produced by background retrieval module. And then these maps are concatenated with query label maps of salient object layout provided by the user. And a convolutional neural network is used to make a feature map. The final feature map obtained by the module contains information about both the layout and its corresponding hallucinated background. This feature map is then passed on to the image generator, which uses speed normalization layers as explained before, and it generates a fine high resolution photorealistic image. Next. The dataset that is used in BachGAN is Cityscape and ADEK20, and the performance metric used has been is pixel accuracy and pressure deception distance. The BachGAN was able to get very good results, state of the art established on these data sets. So that's it from our side. Thank you.
so